So hello guys, welcome back. Today we again have some very good problems from the Allen Score test series. So here is our first question for today. So let's start solving it. You can give yourself a try. Okay, I will do it now. So basically we have a tangent to a curve y equal to f of x at some random point P which intersects the y-axis. So basically tangent intersects the y-axis and normal intersects the x-axis. And then we have been said that the circumcenter of this triangle PAB lies on the line y equal to x. So basically our target is to find out what is this point A and point B so that we can find out the circumcenter. So I will try to draw a rough diagram in this case. Say this is the coordinate axis. And let's say this is some sort of a curve, the curve y equals to f of x. Okay, what I will do is, because we have to take small y equals to small x, so I am writing this out as capital Y equals to capital F of x. Please note that capital F and small f are same. I am doing this to make the notation easy. This is x. So basically if we take a point in this particular region, say this is point P, random point, and this is say x comma y, then this is the normal, and this is approximately the tangent. This is a straight line. So the tangent intersects the x-axis. I'm sorry, the tangent intersects the y-axis at point A, and this is our point B. And we have to, I guess, join point A and point B again with another straight line. And we have to construct triangle PAB. Not construct, actually, I'm drawing this just for your reference. So basically this is our circle. I hope you can understand this is circle. And now we have to find out the circumcenter. Basically this will be the midpoint of the line AB, as you can notice. So roughly this is what we have now. And also one more observation which you can make from here, that this AOPB is a cyclic quadrilateral. So now I guess we will have to find the equations. So to find the equations, it's pretty easy because we have the tangent's equation here will be, I guess, capital Y minus small y equals to f dash x. The slope is basically capital F dash x. Please note small f and capital F are same, and this will become capital X minus small x. Okay, this thing is also capital X. Okay, this thing is also capital X. I capitalize this because because we have to use small y and small x in the straight line equation as well. So if this also becomes small x, you will like wonder why this is small x minus small x, and I'm not cutting this out. So just to avoid any confusions. So this is the equation of our tangent at the point P. Now we can easily find out point A by putting x as 0. So if you put x as 0, I guess this is pretty simple stuff. This will come out to be as y minus, I guess we are putting capital X as 0, please note, capital X. So this is small x f dash x. And now we have to find out the equation for the normal. So if this is the slope of our tangent at the point P, so basically normal and tangent are perpendicular. So this is pretty simple stuff, but I will still write m1 m2 is minus 1, or you can write this as m2 mt mn. So basically if this is capital F dash x, this will be minus 1 by capital F dash x, the slope of the normal. This is capital X minus small x once again. This is again capital Y minus small y. So now if you put here capital Y as 0, because it's intersecting the x-axis, we will have our point B as our small x plus small y capital F dash x, comma, I guess 0. Just a minute. Okay guys, for the time being, just write this thing also as capital X. I'm sorry. You can write this also as capital X. Just don't confuse. I am just using a notation. This is nothing different. You can also use small x if you want, but that will actually make the thing more clumsy and you won't understand anything. You can also like take this point to be some, I should have done that, maybe this was some x naught comma y naught, manipulated everything, and then when at last you will get a differential equation, obviously you can understand from here. At last when you are solving the differential equation, you can replace this x naught and y naught with x and y. You can also do that. So I will proceed to the question. So basically our circumcenter, I'm writing this as CC of our circle PAB, or rather you can say triangle, can denote it like this. This is basically our midpoint of AB. Now if you calculate the midpoint of AB, it will come out to be pretty obvious. This thing divided by 2 and this complete thing. I've just drawn a small dash here. So that's actually the complete dash by 2 and this is the complete dash by 2. Now if you observe in the question, this particular midpoint lies on x equal to y. So what I'm doing is I'm not writing the 2's, basically it will waste time as these 2's on both sides will get cancelled. So basically small x plus y. Now you can write this as dy by dx. Now you will have no confusions. This is equal to y minus x of dy by dx. So let's rearrange this. So basically this is what we have after rearranging. So if you put y as a vx, you will understand that this is a homogeneous differential equation. So basically dy by dx is v plus x dv by dx. So we can put that this is v plus x dv by dx. That is equal to y is vx. So if you put this here, basically those two things will get cancelled. So this is v minus 1 by v plus 1. I hope you can understand what I mean. So now x dv by dx will come out to be v minus 1 by v plus 1 minus v, which is basically your v minus 1 minus v squared minus v divided by v plus 1. So v and minus v get cancelled. So now you can take, I'm taking this common in this step only. This is minus common out 1 plus v square by v plus 1. So you can bring this thing to this side and this complete thing. So this will become integral v plus 1 by I guess 1 plus v square dv equal to integral of minus is left out here dx by x. So after this I'm doing it here. So what you can do now is you can split v by 1 plus v square plus 1 by v 1 plus 1 by 1 plus sorry v by 1 plus v square plus 1 by 1 plus v square. So this is v by 1 plus v square. Now as you can see we can take this to be t, so 2v dv will be dt. So what I'm doing is I'm doing a half into 2 here and this thing will be 1 by 1 plus v square whole dv. This is pretty simple. This is tan inverse v and this is minus of integral dx by x. So this is pretty simple stuff. I will write this out in one step. This is half of, because this thing you can understand I guess, this is half of ln v squared plus 1 plus tan inverse v, which is equal to minus of log x, or you can write ln x also, because I've written ln here I will better write ln x plus c, and this becomes a half of ln y square. V from this part v is y by x, so y square plus x square by x square plus tan inverse y by x is basically minus of ln x plus c. So now we had something given to find out this constant. We had f of 1 as 0. So if you put f of 1 as 0, this is 0 plus 1 by 1, which is half ln 1. Now half ln 1 is automatically 0 plus tan inverse of 0 by 1 is 0, so this is also 0, and ln 1 is again 0, so basically our constant is 0. So I'm writing it, cutting it this off. So this is our final equation. Now we can rearrange this. So this is our final expression after arranging and everything. So basically we were found this is I guess was given as k or n whatever, and this was given as k. So we have to find n plus k. So our answer for this question is 2. This was also a good question. So now we will proceed to the next question. So this is our next question. You can try this out if you want. This is a short and sweet question, but good question. So basically we have a g of given as a function of k comma some z, which is z power k integral 0 to 1 by z t power of t plus k minus 1 dt. Now if we put I am putting this in the limit itself because that's our final expression we have to find. This is limit z tends to infinity z power k integral 0 to 1 by z t power t plus k minus 1 dt. So what I will do is, I guess I did this in one of my previous videos, as you know, infinity is some limit that we don't want to mingle with if there is actually some suitable condition present. So what I will do is I will substitute z as 1 by x, so that as z tends to infinity, from here x tends to 0. So basically this will become limit x tends to 0 integral 0 to x, and this thing is t power t plus k minus 1 dt, and whole divided by, I guess this becomes x power k in the denominator. So now as you can see, this is simple 0 by 0 rule. So now we are fully prepared to apply L'Hopital's. So this becomes our x power x plus, I guess, k minus 1. So what I will do is I will write this as x power x into x power k minus 1 divided by x power k. Okay, we are applying L'Hopital, so this is basically kx power k minus 1. So now this and this get cancelled, so we can keep 1 by k outside, limit x tends to 0, and this is x power x, so I will write this as e power x ln x. I hope you are familiar with this. And we can bring x here also. So this is 1 by k limit x tends to 0 e power of ln x divided by 1 by x. So basically this becomes our 1 by k. I hope you know, I am not telling why this thing is happening. If you have any confusions, you can write on in the comment section, but this is very basic stuff, so I'm skipping this. So basically we have this as 1 by k, and haven't they given something? Okay, we have f of 4. F of 4. So limit this thing was actually, this came out to be 1 by k. This was f of k. So basically our f of 4 is 1 by 4. So k will be 4. So basically xy is equal to 4 and x squared plus y squared equal to 8. This is a rectangular hyperbola and this is a circle. We have to find out the points of intersection of these two curves. So we will solve it now. So this is pretty simple stuff. What we can do is x squared plus this is 16 by x squared equal to 8. So x power 4, 8x square come this side, minus 8x square plus 16 equal to 0. So this is basically x square minus 4 whole square. So x square is 4. So our x is plus minus 2. And from here, y is also plus minus 2. Please remember, plus minus 2, this doesn't mean that with plus 2, both plus and minus 2 are coming. Plus is coming with a plus and minus is coming with a minus. I will write that so that no confusion occurs. Is x equal to 2 with y equal to 2, and x equal to minus 2 with y equal to minus 2. So basically we have to find the number of points of intersection. So basically 2 points of intersection. So our answer for this question is 2. So good question. Let's proceed to the next question now. So here is our next question, guys. Because of some technical issues, I couldn't bring in the printout of the question. So I will read out the question once. I've written this down. This is integral of 1 by x plus 1 by x squared in this bracket multiplied by x minus 1 dx divided by 1 by x power 4 plus 1 by x square in a bracket multiplied by root under x power 4 minus x cube plus x square in one bracket, and that is x multiplied by again x power 4 plus x cube plus x square. This is complete under the root. So this comes out to be second inverse f of x plus c. And if f of 1 is 2, we need to find out the minimum value of f of x. So this was also asked in Allen's score. I couldn't bring in the picture because of some technical issues. So basically this is an easy question. So what we'll do is first we'll manipulate this. This will come out to be as, I guess, x squared. Okay, acha, there is an x minus 1 also. So what we will do is, just a minute. So we will first take the LCM. This comes out to be x plus 1 divided by x square multiplied by x minus 1 dx. We do the same thing here. This becomes x square plus 1 by x square. And now what I will do is I will take out x cube common out from these two terms. So it will come out as x cube because it's becoming x power 6 under root. This becomes our x plus 1 by x minus 1 and x plus 1 by x plus 1. Reason I brought out x plus 1 by x, I guess you guys can see from here only itself if you have done enough questions why I brought out x plus 1 by x. So I will show it anyways. So this will become, what I will do is I will multiply x plus 1 and x minus 1. So this becomes x square minus 1 dx in the numerator, and in the denominator the x, I guess the x squared will get cancelled. Just a minute. Okay, so what I did was I took this x square from here because this is in the denominator's denominator. So I took this to the top, multiplied with this particular expression. I'm sorry, this arrow might mislead you. So x square will go here, this x square and this x square will get cancelled. So basically what we will have is we will be left with only x cube. This x square is not there anymore. Please notice my arrow. So now what we will do is, because we have x cube here and we have x square minus 1 here, so I will basically divide this particular thing with x and this particular thing, I mean the thing in the numerator, this with x and this with x squared. So I guess you can understand this power will get adjusted. So I will write it out in the next step. Just a minute. So this is basically 1 minus 1 by x square. It was x square minus 1, I divided with x square, so this is 1 minus 1 by x square dx divided by x plus 1 by x. The power is adjusted, please note that. And this is root under x plus 1 by x minus 1 and x plus 1 by x plus 1. So basically x plus 1 by x whole squared minus 1. Now I guess you can see why they have given secant inverse. It's pretty obvious now. This is something that you guys all should notice, that if we put x plus 1 by x as t now, 1 minus 1 by x squared dx will automatically come as dt, and this will become integral dt divided by, although we don't have the mod here, but mod is generally when you have no specifications about the sign, and we have f of 1 here. Basically from this we can ascertain that x is positive, so I can put t only. This is root under t square minus 1, which is basically secant inverse integral. So this becomes secant inverse t, which I write off as secant inverse x plus 1 by x plus c. So this is our final equation. Now what they had said is that f of 1 is 2. Okay, f of x is here x plus 1 by x. So they said the f of 1 is 2, which was actually, I guess, why, I don't know why they have given this, because it's pretty obvious from here, maybe to verify. And now we have to find out the minimum value of f of x, which is very easy to do from am greater than equal to gm. So this is by 2 and this is greater than equal to root under x into 1 by x. I will write it down for you guys. This gets cancelled. So x plus 1 by x is greater than equal to 2. So the minimum value of this function f of x is 2. So our final answer for this question will be 2. Now let's proceed on to the next question. So here is our next question, and I guess this will be the final question for today. So basically this looks like a very big question, but this is not very difficult, I will make sure. So basically at first we have three sets of equations. I will write them down. This is x plus y plus z equal to a, and this is x plus 5y minus z equal to b, and this is x minus y plus 2z equal to c plus 2. And it's given that all this particular system of linear equations is consistent. Now if you know what consistent actually means, if you guys know, then you will know that we can, if we take this say to be p1, p2, p3, then we can express actually any one of these planes in terms of the other two planes, because the system is consistent. Basically what it means is that these three planes will be intersecting somewhere, because the intersection of two planes, it makes a line. I will try to draw it out. Here is one plane, and if say another plane intersects it like this, so the intersection of two planes is a line. Anyways, this is not relevant here. So what we will do is we will take p3 to be a p1, small a p1 plus small b p2, where small a and small b are some constants that we will find out. So it's just comparing these coefficients here. So in the first step I will compare all of these. So first equation from here is a plus b equal to 1, and in the second part this is on the RHS minus 1, and this particular thing is a plus 5b. So yeah, now if we multiply this with 5, if we multiply this with 1, this is 5a plus 5b equal to 5, and this thing is a plus 5b equal to minus 1. This is not 56, this is b. Okay, so what we will do is we can now just subtract these two equations. So 4a equals to, I guess, 6. Just a minute. Okay, so guys, what I figured out was, please don't take this as p3 equal to a p1 plus b p2. You can take, there is no problem actually. I'm not saying it's wrong, but if you do this manipulation, it will actually come out in fractions, which will make your calculation very tedious. So what I figured out was, actually if you take p2 as a p1 plus b p3, okay, and I will make this capital A and capital B, because we already have a small a, small b, small c in the question. So if you do this, you will actually get the equations I will write down. This is capital A plus capital B equal to 1, and capital A minus capital B equal to 5. This is actually simpler. The values are coming simpler. So if you add them, this is capital A, 2A equals to 6, so capital A 3, and B will be minus 3 plus 1 minus 2. So these values are, I guess, simpler than the ones. They were coming out as 3 by 2 and minus half, something like that. So I guess you should be also careful about these things, because small things can save time in your exam hall. So basically our P2 is 3 times P1 minus 2 times P3. Now we have that small, we can put the RHS of these three equations, these things, in this particular thing. So basically what we will have is B equal to 3A, I guess, minus 2C minus 4. So 3a minus b minus 2c minus 4, this is 0. And now what they have said in the question is that let P be a plane that is containing all such points small a, small b, small c. That is, in other words, you can actually replace small a, small b, small c with x, y, and z. I will change the page. So this actually becomes plane P. For us, this becomes 3x minus y minus 2z minus 4 equal to 0. So this is our plane P. Now basically we have to, I guess, find out another matrix. I will find out the M matrix first, and then I will go for this whatever shortest distance or something I guess they have given. So this is basically MA minus 2B 2 1C and I guess 103. You can look at the question once. I will show you the question once. Here is the question. I guess I have written correctly. Yeah, it's completely correct. And basically one more thing that we have to find is capital D, which is the distance of the point, rather the square of the distance. You have to find d squared. This is the square of this, the distance of this particular point from this particular plane. So let's find that out. So if you manipulate this determinant, it will come out to be as a 3a, and c into 0 is 0. This is minus 2 times c minus, I guess, b, and this is minus b. So this is 3a minus b minus 2c, and just a minute, this is, I will check once, wait. Okay, I'm sorry, I mistook this. This is not b, this is 6. I'm sorry. This thing is 6. So basically now we have, this is 3a minus b, 2c will come from here itself, this is plus 12, and this is plus 2b minus b, so minus b. So yeah, now this particular thing here, we already have it ready with us. This is 4 plus 12, so our m or whatever it is, it comes out to be 16. Now we find d. And okay, I guess I said something wrong. Minus 2b plus b, nothing like that. This is 6. Okay. Please don't confuse. This is my b and this is my 6. I will try to change my handwriting and maybe use this later on. I'm sorry. This is 3a minus b minus 2c plus 12. Okay. This is 6. So now we have to find our d, the distance, and then we will square it up. So this is basically simple stuff. This is mod of, we have to put 1, 1, 1. So 3 minus 1 minus 2 minus 4 divided by root under 3 square 9 plus 1 square 1 plus 2 square 4. So basically this comes out to be 4 by root 14, because 4 plus 2 6 plus 1 7 minus 7 plus 3 is minus 4. Taking the mod, this is 4. So d square is 4 4s are 16 by 4. I guess we have to find m plus 14 d square. I guess we have to find this. So this was 16 plus 16 by 14 into 14, which is again 16. So this comes out to be 32, which is our option number A. This was a good question, like JEE Advanced PYQ level, you can say. So that's all for today, guys. I guess I will keep it up till this. We'll bring out more such questions in the next videos. Do like, share, and subscribe. And if you guys have demands regarding content, like I should bring out PYQs more or the solutions of any particular book, say, if you want, you can take it out in the comment section and I will try to bring that soon out for you. So please write out whatever you want in the comment section, and do like, share, and subscribe. Thanks for watching.